Okay, we're looking here at number 2 from the test. Number 2 asks us to find a limit. It's the limit as y approaches negative infinity of 2 minus y over the square root of 7 plus 9y squared. This radical in the denominator does pose us a bit of a challenge. We're going to have to do something with that. I'll show you what that is in just a second. But first, I want to do a little work on the side which helps us to understand why this works, why it is that we're going to do what we're going to do. Alright, so let's first of all think about what is the square root of y squared. And you might think it's just y, but not exactly. No, it isn't just y. The square root of y squared means the same thing as the absolute value of y. Yeah, should we try a couple of points to see that that's true? Let's just try a couple of test points. How about the square root of 3 squared? Is that the same as just the absolute value of 3? I believe it is, because 3 squared is 9. The square root of 9 is 3. On the other hand, the absolute value of 3 is 3. So it worked there. Yep. I'll try one more test point. That was a positive value, so maybe that's not convincing. See if this convinces you. How about the square root of negative 5 squared? Will that be the same as the absolute value of negative 5? Let's see. Negative 5 squared is 25. The square root of 25 is 5. On the other hand, what is the absolute value of negative 5? The absolute value of negative 5 is 5. So it worked there as well. These two tests should show you why it's true that the absolute value of y squared, the square root of y squared is equal to the absolute value of y. Okay, this is a useful fact that we're going to take advantage of. I'm sure you would agree with me that if the square root of y squared is the absolute value of y, then that means that the square root of 1 over y squared, right, which is equal to the square root of 1 over the square root of y squared, okay, and the square root of 1 is 1, so this is 1 over the square root of y squared, but we just said that the square root of y squared is the absolute value of y, so this is 1 over the absolute value of y. We're going to be using this in order to simplify this problem. A couple more things to keep track of here. Okay, let's talk about what does the absolute value mean when the y's are positive and when the y's are negative. All right, so I'm going to hopefully we're going to scroll up here a little bit. Yep, scroll up just a little bit. All right, so let's concentrate on the meaning of this 1 over the absolute value of y. All right, well, what that means is this is actually a piecewise defined function in a way. Okay, this is 1 over the absolute value of y means just a regular 1 over y when the y is greater than 0, which means it's positive, right? If y is positive, then the absolute value really isn't doing anything to it. Just bring it right out. On the other hand, 1 over the absolute value of y is 1 over negative y when the y is less than 0. Isn't that so? See, if you put in negative 3, 1 over the absolute value of negative 3 had better become 1 over 3, so 1 over a negative of a negative 3, a negative of a negative 3 is 1/3. Yeah, that works. That is correct. Keep this in mind. That's going to show up when we're doing the limit. Alright, so that was the background information you need to do this problem. Now let's go back and actually do the problem. Alright, so I'm scrolling back over here to look at the actual problem. Alright, so I got to change some things here. I'd really like to multiply something down here so that this y squared, we can kind of reduce it. But the problem is I can't get inside of that radical unless I'm using another radical, which is why I am going to multiply the bottom by, I'm going to multiply the bottom by the square root of 1 over y squared. See that? But if I multiply the bottom by the square root of 1 over y squared, I better multiply the top by the square root of 1 over y squared. Alright, and we'll simplify things now. Simplify things a little bit here. So let's see here. I'm going to leave the top alone for now. So I'm just leaving the top alone. This is 2 minus y. Maybe let's change this into something more useful for the top. Something more useful for the top. I'm going to do a little thing over. This is the square root of 1 over y squared. Keep in mind that that's 1 over the square root of y squared. But keep in mind that that's 1 over the absolute value of y. Can we go a little further? What kind of a limit is this? This is the limit as as y approaches negative infinity. So if the y's are headed towards negative infinity, that means all of the y's are going to be less than 0. And if all of the y's are less than 0, then this part is 1 over negative y. So this top, see right there? This is the square root of 1 over y squared. This is the same as this as long as the limit of the y's are headed towards negative infinity. So I'm going to replace the top with that nicer version for the top. That's a nicer version for the top. Alright, now over. This is a very good version to leave it on the bottom because I can't get inside that radical unless I'm multiplying two radicals. So I'm going to go ahead and leave this. I'm going to go ahead and actually distribute now. But we do have this square root, this big square root on the bottom. 1 over y squared times 7 becomes 7 over y squared plus 9y squared times 1 over y squared is 9y squared over y squared. And can you tell that things are going to simplify a little bit? Keep in mind that this is still the limit as the y's head towards negative infinity, right? Alright, I guess I'll go ahead and let's distribute on the top also now. Okay. Oh, this is a negative y. Let's make that clear that this was a negative y. Alright, so let's distribute on the top also. Try to get this to scroll down just a little bit. Alright, so distributing on the top, rewriting it to distribute on the top. This is the limit as y goes to negative infinity. On the top we have, I'm going to distribute this 1 over negative y times 2. This becomes 2 over negative y. Now it's minus, it's going to be like minus y over negative y, right? Which is the same as, this is now 2 over negative y plus 1. That's what I have on top, right? Down below, we have this square root of 7 over y squared plus, well, this y squared and that y squared cancel, so it's just plus 9. Now, I'm going to rewrite everything so we have it in one nice place. Alright, so let's rewrite everything that we have so far. This is the limit as y approaches negative infinity of 2 over negative y plus 1 over the square root of 7 over y squared plus 9. Now, you see, as these y's head towards negative infinity, we have just a number being divided by something that is headed towards infinity, and so this is just getting smaller and smaller. In fact, it gets as close to 0 as we like. Down here also, 7 over y squared. As the y's head towards infinity, this gets as close to 0 as we like. And so what are we left with? Well, we're left with something very, very close to 0 plus 1, which is giving us about 1. And down here, it's the square root of, well, this is like 0 plus 9, so the square root of 9. This can be then simplified to become 1/3, and that is the answer to this question.